Swastyastu. My name is Nyoman Kesya with name 1913011008 from 3B. I want to explain about set and set applications. Happy watching!
The word set in mathematics is a term that is not definition. Sets are characterized by clearly defined properties of objects or things, either abstract or concrete in them. Thus, an object can determine whether it is inside the set or whether it is outside the set. So, a set is a collection of things. The things in the collection are called elements of the set. For example, the collection 1, 3, 5, 7 is a set which has 4 elements, the numbers 1, 3, 5, and 7. Then, if A is a set, then if an element X is in a set A, we write and see that X is a member of A, or that X belongs to A. If X is not in A, we write then if A and B are sets. If every element of a set A also belongs to a set B, we say that A is a subset of B, or B is a subset of A, and write we say that a set A is a proper subset of a set B if A is a subset of B, but there is at least one element of B that is not in A. In this case, we sometimes write 1.1 definition. Two sets A and B are said to be equal, and we write if they contain the same elements. Thus, to prove that the sets A and B are equal, we must show that A is a subset of B and B is a subset of A. The elements of the set. A set is normally defined by either listing its elements explicitly or by specifying a property that determines the elements of the set. If P denotes a property that is meaningful and unambiguous for elements of a set S, then we write for the set of all elements X in S for which the property P is true. If the set S is understood from the context, then it is often omitted in this notation. For examples, the set consists of two natural numbers satisfying the state equation x to the power of 2 minus 3x plus 2 is 0. Since the only solutions of this quadratic equation are x equals to 1 and x equals 2, we can denote this set more simply by 1, 2, and next a natural number n is even if it has the form n equals to k, k element n, the set of even natural numbers can be written to k satisfying the state k elements n, which is less cumbersome than n element n satisfying the state n equals to k, k elements n. Similarly, the set of odd natural numbers can be written to k minus 1 satisfying the stated k elements n. And then set operation. 1.2 definition is union, intersection, complement. Union. The union of sets A and B is the set X satisfying the stated X elements A or X elements B. And the diagram pen. Intersection. The intersection of the sets A and B is the set X satisfying the stated X elements A and X elements B. And diagram pen. Complement. The complement of B relative to A is the set X satisfying the stated X elements A and X not elements B. And the diagram pen. And next, the set that has no elements is called the empty set and is denoted by the symbol. Two sets A and B are said to be disjoint if they have no elements in common. This can be expressed by writing. And next, 1.3 theorem. If A, B, and C are sets, then the complement of the union of set B and C relative to A is the intersection of the complement of B relative to A and the complement of C relative to B. Okay, to prove, we will show that every element in the complement of the union of sets B and C is contained in both the complement of B relative to A and the complement of C relative to B. And conversely, if X is in the complement of the union of sets B and C relative to A, then X is in A, but X is not in the union of sets B and C. Hence, X is in A, but X is neither in B nor in C. Therefore, X is in A but not B, and X is in A but not C. Thus, X element the complement of B relative to A and X element the complement of C relative to B, which shows that X element the intersection of the complement of B relative to A and the complement of C relative to B. Conversely, if X element the intersection of the complement of B relative to A and the complement of C relative to B. Then X element the complement of B relative to A and X element the complement of C relative to B. Hence, X element A and both X not element B and X not element C. Therefore, X element A and X not element the union of set B and C. So that X element the complement of the union of sets B and C relative to A. Since the set the intersection of the complement of B relative to A and the complement of C relative to B and the complement of the union of sets B and C relative to A contain the same elements. They are equal by 1.1 definition. When it is desirable to form unions and intersections of more than two sets. There are times when it is desirable to form unions and intersections of more than two sets. For a finite collection of sets, their union is the set A consisting of all elements that belong to at least one of the sets A, K, and their intersection consists of all elements that belong to all of the sets A, K. This is extended to an infinite collection of sets as follows. Their union is the set of elements that belong to at least one of the sets A, and in this case we write and similarly their intersection is the set of elements that belong to all of these sets A, and in this case we write for and then application of sets. For is an element N, let An opening parenthesis and minus 1 closing parenthesis K satisfying the stated K element N. Determine the truth value of the statement for all n element N, An subset N, justify. This statement is false. Simply note that for one element N, A1 equals opening parenthesis 1 minus 1 closing parenthesis K satisfying the stated K element N equals 0 times 1, 0 times 2, etc. equals 0, and size 0 is not a natural number. This serves as a counterexample to the claim.
That's all my explain about set and set out application, and I'm deeply apologies if I made some mistakes. Thank you. Santi.